So we might just take the test tomorrow and forget about it.
No, man.
Yeah.
Well, to be fair, it's a less grade, so let's do that one.
Number one, the altitudes of a triangle intersect at the centroid. So, here's the big question. Remember all those things?
We're still on this.
Yeah, we're still on them. That was that thing. So, we had 4 special segments. So first off, you remember the 4 special segments.
Altitude.
Perpendicular bisector, angle bisector, median, altitude.
Perfect. Perfect.
Good.
Holy cow. All right, so what's a perpendicular bisector? Stop, don't say anything out loud, let everybody think for a second. Envision you drawing a perpendicular bisector. What do you have to draw? Shh. Everybody got their answer?
Yeah.
All right, go ahead.
A triangle. You just told me.
Yeah, they're all in a triangle. But a perpendicular bisector in a triangle is what?
Crosses.
It's
A what?
Splits the triangle.
You have to go in the middle. You have to go in the middle of the bottom.
Okay. What you say is kind of right. It splits something in half, but don't say it splits the triangle in half. It splits a side in half. And what? And it has to make a 90-degree angle. So a perpendicular bisector is right in the middle of each side and makes a 90-degree angle. It does not have to come from a vertex. Where do all the perpendicular bisectors meet? At the center? No. Close. At the circumcenter. Okay, at the circumcenter. And what's true about the circumcenter? It's equidistant to the angles. Okay? It's really important. Next one, angle bisector. If I draw an angle bisector, it does what? Bisects the angle, right? Angle bisector. It splits it an angle in half. Has nothing to do with the opposite side. Okay? Angle bisectors meet at the what? Don't guess centroid every time.
Vertex.
Well, it is a vertex, but
Where's that?
in center. Whoever said that, in center. The chart is on page 339. If you want that. Page 339. So the in center is the point of concurrency for angle bisectors, and the specialty of that is they're equidistant back to the sides. Okay? Medians. How do I draw a median? A segment that does what? Yeah. Tell me what that says.
It's the height. No, just
Nope.
kidding. That's the altitude.
Cuts what in half?
Oh, here I have it. What is it?
What?
Median,
Median.
segment that starts at a vertex and goes to the opposite midpoint of the side.
It has to start at the vertex and go to the opposite midpoint, so it goes right to the middle of that opposite side. Where do the midpoints meet? Centroid. Median center, right? Median centroid. Okay? What's true about the centroid? This is the one that was 2/3, 1/3. Remember that? The big part was 2/3, the little part was 1/3. We'll look at one of those in the middle. And then the last one was the altitude. What's an altitude? Yes, it's the height, but what is an altitude? Okay, it has to form a right angle, but it has to, what's the other important part? It has to start from a vertex, okay? What's also important about an altitude is that an altitude could be where with respect to the triangle? Anywhere, right? Could be on the outside, could be on the inside, could be one of the legs. Okay? And they all meet at the ortho center, right? So, seeing Miss Hine looking at her vocabulary sheet, make sure you find that vocabulary sheet because that's due tomorrow also. So, number one, the altitudes of a triangle intersect at a centroid. We just said that one. False. At the what? Orthocenter. The point of concurrency of medians of a triangle is called the incenter. False. The incenter goes with what? Angle bisectors. Exactly right. The point of concurrency is the point at which three or more lines intersect. The point of concurrency, true, right? The point of concurrency are those four weird words that we talked about. Okay? The incenter, the orthocenter, circumcenter, and centroid. The circumcenter of a triangle is equidistant from the vertices of the triangle. That is true. To find the centroid of a triangle, first construct the angle bisectors. What goes with centroid? Is it angle bisectors? No. What goes with centroid? Medians, right? Median is in the center. Go down to number 9. A median of a triangle, okay, so think about that, connects the midpoint of one side of the triangle to the midpoint of another side of the triangle. Is that what a median does? A median goes from the midpoint of one side to the opposite vertex, or the opposite angle. Exactly right. Okay, turn the page. So, make sure you look over all of that vocabulary. It would be very, very important. Maybe we should have a whole vocabulary sheet on the test. That would be interesting, right? Number 11, we're starting out with. Find EG if G is the incenter. So the first thing is, if G is the incenter, what does that mean? What are we dealing with if we're dealing with an incenter? Angle bisectors, right? So, everybody see where G is. So what's true about GF, GE, and GD? Okay. What else is true? They're congruent. E or GF, GE, and GD all have the same measure. So how the heck can I find one of those? Somebody said 90-degree angles. Who said 90-degree angles? Okay. So what's true if I have a 90-degree angle, then I have a right triangle. And anytime that I have a right triangle and I have two of the sides, I can always use what to find the third side? Pythagorean theorem. What's Pythagorean theorem? A squared plus B squared equals C squared. And what has to be my C squared? The what? The hypotenuse, which is always opposite of what? Of the right angle. So, in this particular case, number 11, how the heck would I find it? I'm going to use the Pythagorean theorem with those numbers. Even though they ask me to find EG, I'm really finding GF, but they're all congruent, right? So, A squared, I don't know. What's B squared between those two numbers? 12. And then C squared, is 13. Remember, my hypotenuse always has to be the biggest number. Anybody know what the answer is? This is a Pythagorean triple. This one works all the time. What's this number right here? What's 169 minus 144? What's the square root of 25? 5. So A is equal to 5. So realistically, you should remember that 5, 12, and 13 is something called a Pythagorean triple. Those three numbers will always work. Should have learned that in algebra. Because I know you all love algebra a lot. Okay? But then all of those little segments, FG, GD, and EG would all be 5 in this particular case. Everybody good with this? We look like we're half asleep today. Number 12, what would you call TQ or XW in this case? TQ is an altitude, do you agree? Everybody agree with that? Can it be something else? Can TQ be a perpendicular bisector? It can't. Right? So does it split RS in halves? Yep. So what is RS? 9, right? Because all I'm doing is doubling 4.5. Okay, go over to 13. How do I solve 13? Set those two equal to each other. So just because they're showing us that the segments are congruent on the bottom, it also makes the side segments congruent to each other too. You need to see the math. Just taking those two things and setting them equal to each other. What would we have in in the example to the right? What is LQ, KQ, and JQ? They would all be what? What did they do? They would all be angle bisectors, exactly right. Angle bisectors. So, how in the heck can I find angle QJK? Obviously, they show you the answer. Try not to look at that part, but how can I find QJK? Can I find that? Can I find angle J? Why do you say yes? Exactly right. Did you hear what he said? Because if these are angle bisectors, where they show a 26, the whole thing would be 52, right? And down in the right-hand corner, if they showed it 29, then the whole thing would be 58. So we take 58 plus 52 and do what with that? Subtract it from 180, and then QJK would only be what? Half of that answer. So I'd have to do all that math and then take that answer and divide it by 2. That makes sense? So that's a pretty good problem, actually. Medians and altitudes. Oh, here's your 2/3 one. Go to the example 2 on the right-hand side in section 5.2. It says in triangle EDF, T is the centroid. So again, that's where you got to know that vocabulary. Centroids always go with medians, right? Okay? And what's true about the centroids? If they tell you that FT is 12, how can I find TQ? 1/3 of, not 12 though, it'd be 1/3 of the whole thing, but 2/3 or 12 would be 2/3 of my whole thing, right? 12 would be 2/3 of the whole thing. So I'd find the whole thing and then I would subtract it from 12. You need to see the math there. Kind of how they write it is kind of confusing to me, but it would still work. Everybody okay with that? Then in something like 15, they're talking about the vertices of the orthocenter. Orthocenter, you just have to know that it goes with altitudes, and you would have to draw that out. I think that is an extra credit point again, like on that quiz that we had. Okay. Over to 17 and 18. This talks about our inequalities that we talked about, I believe, the last section before Christmas break. So in number 17, can I say what angles are the order from smallest to biggest? What is the smallest angle in number 17? S, right? Because why? Because it's opposite of 5, right? Now again, don't get confused that angle S is not equal to 5 degrees, right? They just kind of go together. Okay? So what's my biggest angle? T, exactly right, because it's opposite of my 7, right? All right, how about 18? What is the smallest side? So how do I do this one? What do I have to first figure out in number 18? I got to solve for x, and how am I going to solve for x? Add them together and equal to 180, exactly right. Everybody want, or do you want to see the math for that one? So I'm going to add them up, set them equal to 180, then I'm going to take that x and put it back into each individual angle or quantity, and then I'm going to do the opposite like we did in 17, right? Whatever angle is the biggest, then the side opposite of that angle would also be the longest side. Okay? Good with that? Perfect. We skipped section 5.4. 5.5. Is it possible to form a triangle with the given lengths? What do we have to do in this problem? Add them up, and it's got to be bigger than, right? It's got to be greater than. Do I have to do all 3 sets?
Wait, you just added 2 numbers, you added all 3.
I'm going to add 2 numbers and make it bigger than the third number. So I really only have to do what's 2? The smallest, right? So, and I don't remember what number we're on. 26. Would those 3 numbers form a triangle? Okay, how about 27? No, right? 3 plus 4 is not greater than 8. And it can't be equals to. It's got to be greater than. Okay? If it's equals to, and I'm making a tub or something, that's going to be a triangle. It would have, I mean, it would look like it's going to touch, but there would still leak. So it's got to be greater than. Can't be greater than or equal to. 28. Find the range of the measures. We kind of did this a little yesterday, I think. But do you want to see how to do the range one? You want to do 28 or 29? You guys pick. Doesn't matter. 28. So, what do I have to do in 28? Or my 2 numbers, please? 5 and 7. So, we're looking for the third side, right? That would work. But we're looking for a range. So, what has to be true about these 2 things compared to that third side? What does 5 and 7 have to be compared to that third side? Bigger. So we're going to say 5 plus 7 has to be greater than some letter or some variable. Doesn't matter which variable. And then what am I going to do? I'm going to do all the combinations. Then I'm going to say 5 plus x has to be greater than 7. And then I'm going to say 7 plus x has to be greater than 5. Remember doing this? And then I'm just going to solve. So x, or 12 is greater than x. This one, how do I get x alone? X is greater than 2. And this one? Negative 2. Okay? So remember what we said in this kind of problem. What can we always do? Get rid of the negative. Exactly right. So we're going to throw this one out. And we're going to write a compound inequality with this. X is greater than 2 and less than 12. And there's my range. So again, this one's a little different than when we did the range yesterday. Because we could have ended up with a range yesterday because of that variable was put back into a quantity. This one's not really into a quantity. Okay with that? 31 and 32 then would have been what we did for today. Compare the given measures. So first things first, do I have side angle side? Yes. really, we're using all the sides in 31. So see where the 3's are both congruent to the 3's. So I'm using then 2 and 5. So what angle is bigger? ABC is greater than DEF. Is that correct? Now, again, in this one, I don't know why they always use 3 letters, because you could have realistically just said angle B is greater than angle E, right? And I know we say that you should never really look at the angles or look at the pictures, but here you can pretty much tell that angle B is bigger, right? But the math proves it. How about in 32? Again, first off, do I have side angle side? I have side angle side because what other side can I use? The RT, right? Because RT would be congruent to itself by the reflexive property. And so then in this, we're looking at 80 and 15, right? So obviously 80 is way bigger than 15, so what side's bigger? QT is greater than RS, right? So again, it doesn't really matter which way that you would do it. You could have said RS, but then you would have said less than. Let's try 33. This one's actually a pretty good question. Rose and Connor each row across a pond heading to the same point. What are you going to do with Rose, Connor? Huh. Neither of them has rowed a boat before. Connor, come on, man. So they both go off course as shown in the diagram. After 2 minutes, they have each traveled 50 yards. Who is closer to their destination? Well, in this case right here, can we figure this out? Because Rose is only 30 degrees away and Con's 50 degrees away, who's closer? Rose is really closer, right? Sorry, Connor. You got beat by Rose. Oh, you let her win? Not a boy. All right, questions? So,
One of those ones that we did yesterday, like the equal to 180.
yeah. Maybe. Apparently not.
I mean, if there's not on the test, we don't have to, but.
I'll have to look at that in just a second. I think we want to go over to this practice test to the right, though. And go down to 20 through 22. Use the figure to determine which angle has the greatest measure. In number 20, it says, does angle 1, angle 5, or angle 6 have the biggest measure? What would we say? Why? Yeah, remember that? That was that remote interior angles to that exterior angle. The exterior angle is always bigger. So again, this was one of those diagram ones where you had to use the theorem. You can't just say, well, this one's bigger than that one because it looks like it on the figure because they're a linear pair. You had to go by vertical angles or remote interior to exterior. Okay? So look through those other two there and see if you have any questions with those ones. Now see if you have to do what. I was going to say I want to do that one because that one was. Approved. But there will be one of those, like in 20 through 22, that will be on the test. And now we do have to find one of these for Miss Hine because it is on the test also. So, You got good eyes there, big boy. Can you see this little thing way in there? Who's my eyes people? Can you see that little thing there? Can you read those quantities?
For number one,
This one.
The top one, the angle is x minus 3.
Yeah.
Then the other one's x plus 3.
Yeah.
Then the two sides are 10.
This side and this side?
Yeah.
Okay. How about are the numbers down here?
There aren't any.
Well, that doesn't make sense.
No, the middle is reflexive.
What?
Middle's reflexive, just put the two.
I know, but I still gotta have numbers here to tell what's bigger there.
Make something
Take it off the test.
What?
Take the problem off the test and do it.
So that would have been section 5-6, right? What we did yesterday? So, here's kind of, if we're going to write the range for this one right here, here's my side, angle side, right, because this is congruent, and then side, angle side, so I'm using these angles. So between my two sides, which one's bigger if I have 120 here and 115 here? 4x minus 10 is greater than 40, right? So again, because we're talking about sides and I have greater than, I only have to do one thing. If it was less than, then I would have to do 4x minus 10, it's less than 40, and 4x minus 10 is greater than 0. So because it's greater than, I can just do the problem. So I add 10, I divide by 4, and x is what, 54 is 25 halves. And that's my answer. The one with an angle would be like number 6 here. Yeah, let's see that one here. Help me out, Johnny.
Two back ones, 36 and 33.
Yeah.
Both sides are 60. The bottom one on the inside is 3x minus 3, and the top one is 33.
All right. So same difference here, but now we're going to do the angles. So we always start with 3x minus 3 because it has the variable, right? And is 3x minus 3 bigger or smaller than 33? Smaller, right? Because it's opposite of 33. So this is less than 33. If the first one's less than, then 3x minus 3 has to be greater than what? 0. If the first one's greater than, then this one has to be less than 180. Okay? And then we just go back and we solve each one of those, and those are our problems. Okay? So, let's go with the test tomorrow. And then we won't have back to back. And you'll have the whole period tomorrow to work on it instead of a short period on Thursday. So test tomorrow, we'll start, I think, quadrilaterals on Thursday. We'll get into all kinds of